Welcome, viewers. Today we are going to do one trig problem quickly as review, just to go over trigonometry, and then we're going to move into inverse trigonometry. So we'll take a look at slide number 39. First of all, we take a look. We see it's a right triangle. We're only given the length of one side. So that means that we cannot use Pythagorean theorem, because in order to use Pythagorean theorem, we need the lengths of two sides of a right triangle, and then we're asked to find the third length of the side, of one of the sides. That's not that type of problem, right? What about special right triangles? Could we use special right triangles to solve this? It's not special. Unfortunately, triangle, you're not special because of this angle right here is 50 degrees. In order for it to be special, we need it to be a 45, 45, 90 triangle, which it's not, or a 30, 60 triangle, a 30, 60, 90 triangle, which is not. So it's not special. So it's just a regular old right triangle. However, this is 90 degrees, this is 50 degrees. We are given the length of one side. We can use trigonometry ratios, sine, cosine, and tangent, to help us. Using the measure of one angle on the one side, we can solve for a missing side length. So we have to have SOHCAHTOA memorized. Referencing this angle here, 50 degrees, this 8 is opposite, and this n is across from the right angle, so that is the hypotenuse. So opposite and hypotenuse. Which trig ratio uses opposite and hypotenuse? Going once. Good. Sine, right, okay. So the sine of this angle is opposite over hypotenuse. The sine of 50 is 8 over n. That's how we set it up. Let's write it. Sine, and everyone is writing this down, and all the phones should be away. Oh, forgot to put this on. Y'all, my thumbnails I took this morning are fire. You guys are gonna have to help me pick one, because they're all good, all of them. The sine of this angle is equal to opposite over hypotenuse, and that's what you'll have to memorize, opposite over hypotenuse. Opposite is 8 over the hypotenuse is n. Now, this is the tricky part. This is a number. So a number equals 8 over an unknown. We have to solve for that unknown. I showed you 3 ways how to do that last time. The easiest way is to switch the unknown and the sine of 50, location. So really it's just going to be n equals 8 divided by the sine of 50. If you don't like that, you can go back to my video on when I taught trig and look at the other 2 ways to think about it. It's all the same. So in a different color. And you only do that switch when the unknown's in the denominator. So now n is isolated. N equals 8 over the sine of 50. Take out our calculator. I actually added one to the screen. Somehow I remembered. 8 divided by functions. Sine of 50. This problem says to round any decimals to the nearest tenth. So we got 10.44. So 10.4 is the cutoff. We look to the right of that. The 4 after the cutoff determines 4 below, let it go, right? 5 or above, give it a shove. 4 below, let it go. So it's just 10.4. Let's check it. And that seems reasonable, because if I'm looking at this right triangle, this is clearly the longer side. It's across from the 50. This angle has to be 40, because 40 plus 50 plus 90 adds up to 180, which makes, if this is the longer side, this is the hypotenuse. We just found the hypotenuse is 10.4. It's longer than the long side, so it seems reasonable. Done. Moving on to inverse trig. Any questions on that? We're going to slide 41 now. Right triangle. in real life, you're never going to get directions like this that says use inverse trig. So they're just going to say find x. What's x? X is an angle now. It's not the measure of a side. So yes, we do have the length of two sides. So some people think, oh, well, we can use Pythagorean theorem. Well, sure, but Pythagorean theorem would give us the length of the side, and that's not what the problem is asking us to solve for. It's asking us to solve for the measure of this angle. So what we're going to do is we're going to use trigonometry, referencing this angle here. This side is opposite. This side is the hypotenuse. The trig ratio that uses opposite and hypotenuse is sine. We just went over that. So the sine of x equals 30.56 over 34. So let's just go ahead and write that. This isn't normally what we do, but I always do this for the first example so you can see what's actually happening. Sine of x degrees equals, I'm going to leave some space. Okay, so opposite over hypotenuse. Okay? Now, unfortunately for us, the unknown is inside a function. It's inside the sine function. To get it out of the function, we are going to have to undo the sine function. And the only function that undoes the sine function is the inverse sine, and that's the sine with a -1. So I'm going to inverse sine both sides of this equation just to keep it balanced. Like in science, we keep things balanced. So here's what that looks like in a different color. And this is the hardest type of problem you're going to get using trig. If you understand, if you're okay with what I'm doing right now, there's nothing harder. What happens is this inverse sine and this sine, this inverse sine undoes this sine. So those just cancel. And what's left is the x all by itself. It's isolated. That's what we want. Because now we just plug this into the calculator and it gives us the measure of the angle. So to do that, calculator, functions, and you want to push the button with the sine to the -1. The inverse sine of, now let the calculator do the rest for you, 30.56 divided by 34. And this one says round to the nearest whole degree, so that's just going to be 64. And these problems, when you have the units, just type in the number before the unit. So it already says degree, just type the 64 before it, and then your computer will say, good job. Any questions? That's it for inverse trig. All right, thanks for coming out.